my channel. So, this is another video on Google BigQuery. So, in this video we will see how we can query public data sets, and also we will see how we can add them, and also we will see what is the concept of wildcard tables and how we can query them, right. And also we will see a concept called parameterized queries. Okay. So, what are the different options we have to execute those parameterized queries, right. So, first of all we will try to understand what is the public data set. So, public data set stored in the BigQuery, it is available for public to query. Okay. So, for that, right, as a user you do not have to pay for the storage, right. BigQuery will take care of that. You will be paying only for the query processing whenever you try to query a public data set. Okay. So, you can query public data sets using different options available, right, like console and also command line tool and also Python API client libraries, right. So, you pay only for a query process, and there is a concept called 1 TB is free. This option is available per month for every user. After that they are gonna charge for extra processing. Okay. So, querying public data sets using standard SQL or also legacy SQL. You can query public data sets using one of this option. Okay. So, in the next task we will see what is a parameterized queries, right. So, parameterized query, yeah, right, it can be constructed using user inputs. That means, so you will be passing parameters values exactly while executing the query. Okay. We will see those examples in detail. Okay. So, this feature is available through standard SQL syntax. Okay. And it supports, there are two different types of parameters. One is named parameter, one is positional parameter. In case of named parameter, you will have to notate or define the parameter using the symbol @ the rate. In case of positional parameter, you will have to notate or define that parameter using the question mark. Okay. This is one such example where if you see, it look like a normal SQL query only, but only difference is here. If you see, I am trying to filter some data where corpus is equal to some parameter, where word count greater than or equal to this parameter. That means you do not have the actual value of this filter at this moment, but you will be passing these values when you are exactly running this or executing this SQL query. This parameter will be substituted by those actual values. This is called parameterized queries. Okay. So, how it is helpful? What is the advantage you are getting when you are using parameterized? In case of, in order to avoid some SQL injections, definitely you can use parameterized queries, and also if you have to reuse some query in multiple or many cases, definitely you can go for parameterized queries. Okay. This feature is not available through Google Cloud Console, that is edited, but this is, you can run parameterized queries using BQ command line and also REST APIs and also client libraries like Python. Okay. Hope you understand. This is one parameter, this is one parameter if you observe this query, right. Now, in the last task we will see what is a wildcard table, what are the advantages, right, and then we will see some limitations. So, first of all, let us try to understand what is wildcard table. Let us say there is a data set available in the project, it has this kind of tables like table _1, table _2, table _3. That means it has the same or similar name pattern, only difference is this _1, _2, _3. So, if you have to query these tables, what you will do, right? If you have to query all these tables in one go, what you will do? You will be writing a individual queries and you will be using union in between them. Okay. What happen if there are many more such tables available, like 20 to 30 tables with this pattern _1, _2, _3 up to _30. In such case, you will have to write a lengthy query, right. So, it will become very difficult to maintain that query in future. In such case, BigQuery, to mitigate that, BigQuery is offering very unique or rare feature, right, that is called wildcard table query, right. So, what you will do, you will be using this particular pattern _*, right. That means you can query all such tables which are matching this wildcard character. Star is a wildcard pattern. So, you can substitute this star with all wildcard characters like under 1, 2, 3, 4 up to 30. That means this star will hold multiple list of values from 1 to 30 in such case. So, you can query with a using a simple query, right. You can query all 30 tables using a simple query, right. This is called wildcard table concept. Okay. And also this wildcard table is also providing a pseudo column. Each row will consist this particular pseudo column table underscore suffix. So, this particular pseudo column will hold all this list of wildcard characters, in this case 1 to 3, right. So, you can use this pseudo column while filtering these wildcard tables. For example, let us say I have 30 such tables 1 to 30, but I would like to query only 1 to 15. What you will do? You will use between class, you will use this pseudo column table suffix between 1 to 15, simple, right. So, this is how it will be very much useful, right. And there are some limitations also where, so you cannot use this feature for views and external tables, and also if the tables are partitioned incompatible partition, it is a mix of partition. Let us say one table is partitioned based on timestamp, another table is partitioned on a different parameter like integer. In such cases you cannot use this feature, it is an incompatible partition, right. It is not a uniform partition, right. And also the schema is mismatched. For example, let us say we have table 1, table 3, table 1 is having column 1 as a data type string, table 2 is having column 1 as a data type as an integer or some other data type. In such cases also this feature is not supported. There are many more limitations also. For that, please refer to the official documentation. Okay. I hope you understood this concept, right. Now, let us quickly go to the demo. In the demo, in the first task we will see how we can add public data sets and how we can query public data sets. We will also try to explore few public data sets, and also the second task we will see how we can write parameterized queries using BQ command line tools and also Python API. Okay. And also we will see a concept called parameterized queries and also named and positional arguments. Okay. In the third task we will see wildcard table query. Okay. Let us quickly go to the demo. Okay. Right now I am in my Google Cloud Console BigQuery editor. First of all, we will try to add some public data sets. For that, simply go to this search. Okay, just type enter, type public and then enter. You can see there are public data sets available. Okay. So, this is a public project. So, just try to pin this project, that is it, right. Then you should be able to see this project is available. Just try to click this arrow. You can see there are many more public data sets available. These are the different public data sets available. So, which is storing different data from different industries or different type of data, right. COVID related data, sports related data, crime related data, tax related data, like that there are many data sets like. So, this will be very much useful to learn to write complex SQL queries, and also you can analyze the data. You can use this data for learning machine learning, create and deploy machine learning models for testing purpose. Okay. Right now, we will try to explore few public data sets. This is okay, one such data set and one such table, right, commits. Let us go to type. In order to filter any particular table, just take that table name and just paste that table name over here and just enter. You can see then that all that data set list and table list will be filtered out. Now, you can see this table. So, this belongs to this data set GitHub repos, you can see. So, it has this kind of schema where we have nested and repeated fields. Let us try to preview the data. For preview, you do not have to pay anything. It has 261 million records, right. Now, we will see, as I already told in my introductory video, BigQuery is a data warehouse in the Google Cloud platform. So, you can query petabyte scale data. That means response will be very fast in case of large tables, right. Now, we will try to query this table, right, using some basic queries. Now let me run this first query, which is doing some simple count of records from that table. Just run this, you can see the record count, right. The second query, what I am trying to do, I am performing some simple aggregation where I am trying to count the number of commits grouped by author name. So this author is a nested field. Inside this nested field we have a column called names. Now I am just counting the number of commits grouped by author name, right. So let me execute this query. It's gonna scan this table, 261 million records. Just run and see the response. Response is very fast, right. You can see it processed almost 13.64 GB of data. You can see the response. Okay. So this is how you can query public data sets. So like this, there are many public data sets to explore. Okay. I hope you understand this concept. Now let us move to the next concept called parameterized queries, right. As I already told, parameterized queries, when run parameterized queries using PQ tool or client libraries. In the first case, we will see how we can execute or run parameterized queries in the using BigQuery tool, right. So we will use BigQuery tool, BQ. This is a query keyword. So here you have defined a query to run, right. Here also I am trying to query public data sets. If you see this query, I am trying to query this COVID related data set, where I am just trying to filter the data and also aggregate the data. I am trying to filter the data based on the country, passing India as a input parameter and also date. I would like to filter the data based on the data. I would like to fetch the data which is less than or equal to 2022, and also I am performing a group by based on the month and year, and also I am getting the sum of confirmed COVID cases. This is that query. Okay, you can see I am using named parameters over here because I am using this @ symbol. This is country is one parameter, date is the other parameter. If you see parameter 1, so this is a syntax to follow. You will have to specify the parameter name in the first place, second place type of the parameter, data type, third place actual value of the parameter. In case of string, you do not have to specify the type explicitly by default. If you do not specify anything, it will consider that as a string. If you see the second parameter, date is the data type and this is the value. Now let us try to run this query. It's a parameterized query because you are passing the values while executing this query, right. Now let us clear this up and paste this query. Now run this query. You can see the results, aggregated data, right. We will try to see the next query. So next query also same thing, right, but only difference is here I am trying to use positional parameters, right. I have used this question mark, right. Same thing. Now I did not mention any parameter name here, it is an empty. I mentioned only data type and the value, right. That is the only difference. If you do not mention any parameter name, it will consider it as a positional parameter, right. Now we will try to run this query as well quickly. Just type you can see the result, right. Same query, same result. Now let us go to the next query, right. So in this query, what I am trying to do, I am trying to pass two parameters. One is string data type, but you see this is the array data type. I am just passing list of values, so right. But here while passing this parameter, since it is array, you will have to unnest before passing that value. Unnest is a keyword to unpack the values which are of type array. So we will try to discuss about this keyword in detail in upcoming videos. Okay. Now let me try to run this query. Again it is a name parameter, right. So in the last query, it is a simple query where I am just passing a struct parameters. It is a record type, right. We have two different values, right. two different columns, x is a one integer, y is a string, right? It is a simple query just to demo different options available, right? What are the different parameters you can pass to a query? You can pass any kind, any type of parameter like array, struct, string, integer, date, right? You can see the result. This is how you can execute or run parameterized queries using BQ tool. Now we'll see how we can execute or run parameterized queries using client libraries. I am using Python. So this is a simple program where I am just trying to construct BigQuery client, and this is a simple query, the same query I have been using, right? So I am just trying to aggregate this data using the best after filtering the data using country and date, right? And then here I am defining the parameter, right? These are the named parameters, right? Parameter name, type and value, right? Once I have the results into this variable, right, I am trying to print those results using for loop and formatting the results. It's a simple query. So this is a programmatical way of executing your parameterized queries. It will be very much useful when you are trying to use this concept while defining any data engineering pipeline or while developing any other pipeline. Okay. So let me execute this script, right? I have the script. This is the script. Now it should, once it executes, it should immediately return the results, right? You can see the results are written. This is how you can use parameterize, or you can execute parameterized queries using client libraries, right? So now let's go to the wildcard table concept, right? So here also I have been using public datasets. So let us try to explore this table, right? So let us go here, just type the table name, enter. You can see these are the similar tables with the same naming pattern, only difference is year 14 to 16, right? Now I would like to query all these tables using that wildcard pattern, right? So I am just aggregating, like I am doing it group by, and I am trying to find maximum passenger count and minimum passenger count. Basically it is a trips related data, cabs trips related data, or taxi trips related data. Okay, let me try to run this query. Okay, so this is a wildcard pattern, right? 20. So this star will have the list of values from 14 to 18 now. Now it should query all these tables and it should result the data after aggregation, right? So see the response, very quick, right? So we'll see the second query. So in the second query we are trying to query a group of tables which are having this pattern. Let us try to find this table. How many such tables we have? We have so many such tables. Basically it's a weather data. So we have one table for 1 year, and the table is having daily weather related data, right? Now we'll try to demonstrate the concept of this pseudo column. As I already told, this pseudo column holds all the wildcard characters in the list form. That means we have almost 40 to 50 tables it seems. It holds all the values from 29 to maybe 40 or 41 based on the table number, right? Now I would like to query tables between 29 to 35. So like this you can use between class, or else less than 29 or greater than 35, something like that. Okay, so in such case this is very much useful. Let me try to query. You can see, right? So the result. So now the star will have the list of values from 29 to 35, right? And also if you specify something like this, you will have to give values like this. To 9, that means 1934 to 1939. Okay. So there are some best practices also mentioned in the documentation. For example, let's say if you are using this wildcard tables, so this is called prefix, this is called postfix, that wildcard character is called postfix, suffix, sorry, this is called prefix. If you use lengthy prefix and shorter suffix, the performance will be better. Okay, so always try to keep that in mind for better performance. Okay, so I hope you understand this concept. So we'll meet in the next video. Thank you all.